This is a key to test 2, and the first 5 problems you'll notice it does say factor completely. All right, so number 1, you want to factor this trinomial. It's a quadratic trinomial, and remember when factoring, always look for a greatest common factor first. And so if you notice those 3 terms, the greatest common factor of those 3 terms is 1. So since the greatest common factor is 1, we're going to go ahead and factor this as 2 binomials. And remember, always use those little rules that you've learned. For example, if the last sign's negative, that means the signs in here are different because a positive times a negative times a positive is a negative. All right. So remember things like that. If the last sign's positive, that means the signs within the parentheses are the same. A negative times a negative is a positive times a positive is a positive. All right, so keep in mind those little rules that you've learned through the process of factoring. But in this case, this is an easy one because the coefficient of x squared is 1, so we're going to have x times x is x squared. And for negative 24, let's go ahead and use positive 4 and negative 6. And that's going to work because remember, always check your work because you want that middle term to be a negative 2x. So if you look at the outer is a negative 6x, the inner is a positive 4x, and when you add them up, you get negative 2x. So that's the answer for number 1. All right, and number 2, again, the GCF is 1. This one's a little bit. This one's easier as well because the coefficient of x squared is prime. So there's only one possibility for 3x squared, and that is 3x and x. Now, 6 is not prime, but it's not a difficult number to deal with. But notice again the signs in the middle. I'm sorry, the last sign's positive, so that means that the signs within the binomials here will be both negative, and negative because of the middle sign. And so let's try 3x and x, because 3x times x is 3x squared. For a positive 6, let's go ahead and use a negative 2 and a negative 3 and put the 2 with the 3x term. And always check, because you could have made a mistake and put them in the wrong place. But the outer, if you notice, the outer is a negative 9x, the inner is a negative 2x, and when you add them up, a negative 9 and a negative 9x, and a negative 2x is a negative 11x. And then a negative 2 times a negative 3 is a positive 6. All right, now in number 3, again, look for GCF. The GCF here, now this is 8x cubed. The GCF here of 8x cubed and a negative 16x squared and a negative 10x is a positive 2x. I'm going to go ahead and write that here. So that's 2x. So I'm going to factor out the 2x first. And so when I factor out the GCF of 2x, I'm going to get 2x times 4x squared. So again, 2x times 4x squared is 8x cubed, and then 2x times a negative 8x. Negative 8x is a negative 16x squared, and 2x times a negative 5 is a negative 10x. Now let's go ahead and factor this trinomial. And so when I factor this, I'm going to go ahead and factor that trinomial here. So when I factor that, this one's not that bad either because the coefficient of x squared is 4, and there's only two possibilities, 2x, 2x, 4x, and 1x, and the last sign's prime. The last term, rather, is prime. But again, don't forget about the middle, the last sign's negative, so these signs in here have to be different. And for that one, let's try 2x and 2x. So 2x and 2x is 4x squared. For negative 5, there's only one possibility, 5 and 1, so it does not matter where you put the 5 and the 1 because the first terms are identical. So let's put negative 5 here and positive 1 here. And the 5 has to be negative, the 1 has to be positive. And let's check ourselves. Remember, you want that negative 8x in the middle, in that middle term. So the outer is a positive 3x. 2x, that's a 2 here, 2x, and the inner is a negative 10x, and when you add them up, you get negative 8x. All right, and so the answer, don't forget the GCF, so I'm going to put that here. So the answer is going to be 2x times 2x minus 5 times 2x plus 1. Okay, in number 4, notice that this is the difference of two squares, so you can factor that as 4x minus 5y times 4x plus 5y. All right, again, check by foiling this out. So the first 4x times 4x is 16x squared. The outer is a positive 20xy. The inner is a negative 20xy. Those add up to be 0. So notice there's no middle term here. And the last negative 5y times a positive 5y is a negative 25y squared. And then over here, so for this one, it looks like this is a perfect square trinomial because 36x squared is a perfect square, 25y squared is a perfect square. So in other words, when you look at this in terms of 6x and 5y, when you multiply 6x and 5y, that is 30xy, and then doubling it gives you that. So that's a perfect square trinomial, meaning that when you factor it, the two binomials are going to be identical. So it'll be a binomial times itself. But this is going to be, and again, the GCF is 1 here, but that's going to be 6x, and the last sign's positive, so that's going to be negative, negative, because you want the middle sum to be negative. And then 25y squared is going to be 5y, 5y. And then if you check it, it does give you this. 6x times 6x is 36x squared. A negative 5y times a negative 5y is a positive 25y squared. The outer is a negative 30xy. The inner is a negative 30xy. When you add them up, you get negative 60xy. And again, you could have written it as 6x minus 5y squared, just like we had said here. All right, so that was number 5. Okay, now let's look at number 6. So now in number 6, you want to simplify the rational expression for number 6. All right, so first thing you got to do, remember, is to factor the numerator and factor the denominators. The first thing you have to do, factor numerators and denominators. So in the numerator, what I had to see was this. I had to see that being factored. So you can factor that as 2x plus 3 times x plus 2. And the denominator, that can be factored as x plus 2 times x minus 3. All right, so first thing you have to do is do that. So you have to factor the numerator and factor the denominator. The next thing you have to do is reduce. You have to show what's being reduced. So these two factors can be reduced. But remember, when you divide those out, you're left with factors of 1, because 2x plus 2 divided by 2x plus 2 is 1. 2x plus 2 divided by 2x plus 2 is 1. And so therefore your final answer then will be 2x plus 3 divided by x minus 3. All right, so there's the work. There's the answer. Okay, now in number 2, same directions. So this time you're going to factor the numerator as p plus 6 times p plus 3. The denominator can be factored as p plus 3 times p plus 1. And then once you factor, the next step is to reduce. So you got to show what's being reduced. So the factors of p plus 3 can be reduced. So that's going to be 1, that's going to be 1, and you get p plus 6 times 1 is p plus 6. 1 times p plus 1 is p plus 1. And so there's your answer there. The next one, number 8. So number 8, let me go ahead and write this a little bit better. So that's 6x squared plus 2x divided by 9x squared minus 1. All right, so for 6x squared plus 2x, the GCF here is 2x. So I'm going to go ahead and factor out a 2x. And when I do that, I'm going to get 2x times 3x plus 1. The denominator, that's the difference of two squares, so I can factor that as 3x minus 1 times 3x plus 1. So now the next thing you have to do was to reduce these common factors. So you have to show it. So you got to do this. You have to show that you are reducing those. And so the answer will be 2x times 1 is 2x divided by 3x minus 1. All right. So that's number 8. Now let's look at number 9. So number 9, we have this for number 9. All right, so now you want to start performing certain operations. And in this case, you want to multiply these two rational expressions together. Okay, so when we do that, we got, again, just as before, you got to factor the numerators and factor the denominators. Now, in that first rational expression, the numerator, those are monomial factors. I'm going to leave those alone. X plus 4, the GCF is 1. Nothing you can do there. But in this rational expression, I can factor both numerator and denominator. So let's go ahead and do that. So I'm going to get x squared divided by x plus 4 times, all right, I can factor this numerator as x plus 4 times x minus 2. The denominator, I can factor out an x, so it'll be x times x minus 4. All right, and so now reducing, see, I have two factors of x here. I have one right here, so I can divide that with one of these, and so you're left with one factor of x here. Here I have an x plus 4. I see one here, so I can divide those out. You're left with factors of 1s in their place, and that's it. There are no other factors you can reduce. So therefore, your answer is going to be x times 1 times x minus 2, which is x times x minus 2, divided by 1 times x minus 4. And leave your answer in factored form. Don't multiply it out. If you multiply it out and you get a mathematical error, you're going to lose points. All right, now, the number 10, you have, I'm going to go ahead and write this a little bit better. So it'll be x squared minus 25 divided by x squared minus 1 times x plus 1 divided by 2x plus 10. Okay, so again, just like we did this one, you're going to factor numerators and denominators, and then you want to multiply these two rational expressions together. So the numerator and the denominator are both difference of two squares, so I can factor the numerator here as x minus 5 times x plus 5, and the denominator I can factor as x minus 1 times x plus 1. The numerator, I cannot factor x plus 1, so I'm going to leave it as x plus 1. The denominator, I can factor out a 2, so I get 2 times x plus 5. All right, and then once you factor, the next step is to reduce common factors. And so notice I have an x minus 5 here. I don't have any as a factor in the denominator. I have an x plus 5 as a factor in the numerator. I have 1 right here, so those will divide out. Factors of 1's in their place. X plus 1 right here, I can divide those out. And so therefore, and remember, make sure you put factors of 1's. So therefore you get x minus 5 times 1 is x minus 5, divided by x minus 1 times 2 times 1. And we always tend to put the monomial factor in front, especially if it's a coefficient. So it would be 2 times x minus 1, numerical coefficient of 2. Again, if you multiply it out, nothing wrong with that, but if you make an error, you're going to lose some points. All right, so leave it in factored form. Leave it in factored form. All right, so there's number 10. Okay, now, so that's number 10. Then number 11, this time you're beginning to divide. So now you're dividing these rational expressions. So let me go ahead and write this better so you can see it. So it'll be x squared plus x minus 12 divided by x squared plus x minus 6 divided by x squared plus 5x plus 4 divided by 3x squared minus 6x. All right, so first thing you want to do is change this division to multiplication problem. So let's go ahead and do that first. So remember, to change a division multiplication, you're going to multiply by the reciprocal of the fraction following the division symbol. So the first rational expression stays as it is. So it'll be x squared plus x minus 12 divided by x squared plus x minus 6 times the reciprocal. So that's 3x squared minus 6x divided by x squared plus 5x plus 4. All right, so then we're going to factor. So factor the numerators, factor the denominators. So the first numerator I can factor as x plus 4 times x minus 3. The denominator I can factor as x plus 3 times x minus 2 times, now be careful here, that's a binomial, so notice you do have a GCF other than 1, so the GCF here is 3x, so I can factor out 3x, and I get 3x times x minus 3, In the denominator, the GCF is 1, but I can still factor this as two binomials, which is x plus 4 times x plus 1. All right, so once you factor, the next step is to reduce. Divide out common factors, and you got to show what's being reduced. So the first factor is x plus 4. I have one right here, so those divide out. Got to show it. The next factor you see in the numerator is x minus 3. I don't have any in the denominator, so that stays x minus 3. The next factor is 3. I don't have a factor of 3 in the denominator. The next is an x. I don't see a factor of x in the denominator. The next one is an x minus 3. I don't see one down in the denominator either. Make sure, let me make, oops, sorry. That is 2 right here. Excuse me, x minus 2. So that's x minus 2. Sorry, 3x times x minus 2. 3 times a negative 2 is a negative 6x. So I made an error there, so fix that. So that's x minus 2. Now those divide out. See one here, right? And that's about it. So I don't think I made another error anywhere. All right, so therefore the answer is going to be 1 times x minus 3 times 3x times 1. And always put the monomial factors first. So it'll be 3x times x minus 3 divided by, and then x plus 3 times x plus 1. And leave it in factored form. If you multiply it out and you make an error, you're gonna not get full credit. So leave it in factored form. All right. Okay, so that's number 11. Number 12, let me go ahead and write it so that you can see it better. So number 12, we have this. We have x minus 3 divided by 5x minus 5, and that rational expression is being divided by this rational expression, 6x squared divided by 30x cubed minus 30x squared. All right, so first thing you want to do is change this to multiplication problem. So remember, always multiply by the reciprocal of the fraction following the division symbol. So I get x minus 3 divided by 5 x minus 5 times the reciprocal. So it'll be 30x cubed minus 30x squared divided by 6x squared. All right, so now we're going to factor. In terms of the first rational expression, the only expression I can factor is the denominator. So I'm going to write this as x minus 3 divided by 5 times x minus 1 times, now in the numerator, the GCF here is a 30x squared. So that becomes 30x squared times, and then 30x squared times x is 30x cubed, and then 30x squared times a negative 1 is a negative 30x squared, divided by 6x squared. All right, now let's go ahead and reduce. You got to show what you're reducing. So I see an x minus 3 as a factor. I don't have any in the denominator. I have a 30 as a factor here. I can factor that 30 with the 6 right here. So you're going to say 6 into 6 is 1. 6 into 30 is 5. But I can factor that further because you see 5 occurring here also in the denominator. 5 into 5 is 1. 5 into 5 is 1. Okay? The next factor C is an x squared. There are two factors here. I see two of them right here as well. So those divide out. So those factors of x squareds divide out. And then I see an x minus 1 here. There's one right here. So those divide out. And that's all I can reduce. So I get x minus 3 times 1 times 1 times 1, which is x minus 3. The denominator, 1 times 1 times 1 times 1 is 1. But go ahead and write this as just x minus 3, because we all know that x minus 3 divided by 1 is just x minus 3. All right, so that was number 12. Okay, number 13. So in number 13, this is where you are going to begin adding and subtracting. So remember, when adding and subtracting, we go ahead and write this right here a little bit better. So you get 5 divided by x minus 6 minus 2 divided by x plus 2. All right, so in adding and subtracting, you can only add and subtract rational expressions that have that same denominator. So notice the denominators are not the same. So the first thing you have to do is factor the denominators, and then you find your LCD. But notice that x minus 6 and x plus 2, I cannot factor. So the LCD is going to be a product of all the different factors that you see in the denominator. So I see an x minus 6. That's going to be part of the LCD. I see an x plus 2. That's part of the LCD. Now remember, the least common denominator is a product of those factors. So don't separate them by commas. That's not the least common denominator. The least common denominator you have to write as a product. So you got to make sure you write it as x minus 6 times x plus 2. Now, you're going to write, let me go ahead and rewrite this right here. So you're going to write equivalent fractions now. So once you find the least common denominator, you're going to write equivalent fractions. Now, so you want to rewrite this fraction and this fraction with a denominator that looks like this. So let me go ahead and rewrite that. So I'm going to put the denominator as x minus 6 times x plus 2, which is the LCD. Don't forget you're subtracting. That's why you see a subtraction symbol here. And then x minus 6, x plus 2. All right, now to write equivalent fractions, to determine what fraction, 5 divided by x minus 6 is equivalent to what fraction with that denominator, you got to think about what you need. So I have an x minus 6 already, right? So you have the x minus 6, what you're missing is the x plus 2 here. So you got to say times x plus 2. But what I do to the denominator, I have to do to the numerator. That's x plus 2. All right, so this numerator comes here now. So it'll be 5 times x plus 2. Kind of makes sense because if you divide, if you kind of cover that up, you get the original expression back. All right, so that expression is equivalent to this one. Do the same thing here. So I have x plus 2. What I'm missing is x minus 6. So you can say times x minus 6 times x minus 6. And so that numerator goes here. So 2 times x minus 6. All right, now since I'm subtracting, you got to be careful. So now since the denominators are the same, I can write this as one rational expression with that denominator, with that common denominator. And so you're going to say the numerator minus this numerator. Okay, now let's go ahead and distribute. So we're going to distribute the 5 here, and we're going to distribute the negative 2 here. And so when I do that, I'm going to get 5x plus 10 minus 2x plus 12. A negative 2 times a negative 6, a positive 12. So minus 2x plus 12 divided by, and leave it in factored form. Don't multiply it out because you still, at some point you want to see if you can reduce any common factors. So when I combine like terms in the numerator, I get 5x and a negative 2x is 3x. 10 and a positive 12 is a positive 22 divided by x minus 6, x plus 2. Now at this point, that's where you want to factor the numerator and see if you can reduce. But I cannot factor the numerator. The GCF here is 1, so that's all you can do. All right, in number 14, same thing. Our problem's going to, let me go ahead and rewrite it. It's 3 divided by 5x plus 10 plus 2 divided by 3x plus 6. All right, so remember, in finding the least common denominator, you cannot add those rational expressions right now because the denominators are different. So you got to find the least common denominator. To find the least common denominator, you got to factor the denominator. So when I do that, right here, this is 5 times x plus 2. And when I factor out the GCF here, that's 3 times x plus 2. So the least common denominator is a product of all the distinct factors that you see. I see a 5, I have to use it. I see an x plus 2, I have to use it. I see a 3, I have to use it. I see an x plus 2, I already have it. So don't put it again because it's no longer the least. You've now found a common denominator, and if it's not the least, it makes things a lot more difficult for you. But write 5 and 3 as one product. So it'd be 15 times x plus 2. So that's your least common denominator. Now we're going to, just like we did here, we're going to write equivalent fractions. So let me go ahead and rewrite this rational expression as 3 divided by 5 times x plus 2 plus 2 divided by 3 times x plus 2. All right, so we're going to write equivalent fractions with a denominator of 15 times x plus 2. All right, just like this, 15 times x plus 2. And just like in the previous problem, you're going to ask yourself, this is what I have, this is what I want to end up with. So 5, I have a 5 here, and an x plus 2, I have an x plus 2, and I have a factor of 5 in this 15. What's missing is this 3. So I got to say times 3 times 3. And so the numerator, 3 times 3 is 9. So that goes here. Same thing here. At 3 times x plus 2, I already have a factor of x plus 2. I have a 3, but I need a 15. So I got to say times 5, because 3 times 5 is 15, But what I do to the denominator, I do to the numerator, and so 2 times 5 is 10. And now I can add these up, and that's easy to add because the numerators are just numerical numbers, numerical expressions. So 9 plus 10 is 19. So I get 19 divided by 15 times x plus 2. And there's nothing else you can reduce, so that's your answer. All right, and then finally number 15. This time again you're adding two rational expressions. Let me go ahead and rewrite this over. So it'll be 3x minus 1 divided by x squared minus 4 plus 5 divided by x minus 2. Okay, so again, notice that you're adding these. The denominators are not the same, so you got to find the least common denominator. Before you find the least common denominator, you got to factor your denominators. Now, over here, this x minus 2 is a prime factor. So the GCF is 1. It can't do anything else. Here, though, that's the difference of two squares. So I can factor that further as x minus 2 times x plus 2. And so now once you factor your denominators, you can now find the least common denominator. The least common denominator is a factor of all the distinct factors that you see. Is a product of all the distinct factors that you see. I see an x minus 2, it has to be in the LCD. I see an x plus 2, it has to be in the LCD. I see an x minus 2, it has to be in the LCD. I already have it. Don't put it again because there's no longer a least. It's a common denominator. And if you don't use the least, what you end up with makes it much more difficult for you to work with. So once you find the least common denominator, now you're going to write two equivalent fractions with that denominator. So I'm going to write two equivalent fractions with this denominator. X minus 2, x plus 2. X minus 2, x plus 2. All right, so notice I have 3x minus 1 divided by x minus 2 times x plus 2. Notice that this denominator is the same as the least. Okay, so that means if I multiply this by 1 and this by 1, then the numerator has to be the same as this numerator here. 3x minus 1 times 1 is 3x minus 1. So whenever you're writing equivalent fractions and the denominators are the same, then the numerators have to be the same because of this fact that you're multiplying both of them by 1. Over here, though, see I have an x minus 2 already, but I'm missing the x plus 2 here. So I got to say times x plus 2. Once I multiply by x plus 2, see this is now going to be the denominator, but what I do to the denominator, I do to the numerator. So this becomes 5 times x plus 2. All right, now once you write two equivalent fractions with the same denominator, those rational expressions are the same with the same denominators. So now you can add the numerators together because you're adding here. So let me go ahead and write the denominator as x minus 2x plus 2. And the numerator will be 3x minus 1 plus 5 times x plus 2. Okay, now distributing the 5 here, this becomes 3x minus 1 plus 5x plus 10 divided by x minus 2, x plus 2. Again, leave things factored because at some point the numerator may be able to a factor in the numerator may be a factor in the denominator you want to reduce if possible. So leave it in factored form. The numerator, 3x and 5x is 8x. A negative 1 and a positive 10 is a positive 9. And the denominator is x minus 2, x plus 2. The next step, if possible, is to factor the numerator and then reduce any common factors. Notice, though, the GCF of 8x plus 9 is 1, so that's a prime factor right there. So that's your answer. That's all you can do. So that is, let's see, so that is the key to, this is a key to test number